This is my new open-source 3D LiDAR. It scans its environment using a mirror that rotates on two axes and a TF Mini or TF Luna laser distance sensor. This design does not have any moving electronics parts. To achieve this, the mechanism works somewhat similarly to an helicopter's thrust plate. The axis that tilts the mirror operates independently from the yaw rotation axis. The tilting is done with two servos, while the rotation is performed with a single NEMA 17 stepper motor with gear reduction. I designed this model in SolidWorks and 3D printed all parts on my Anet A8 with 0.2 mm layer height. The only additional parts are 15 M3 by 6 mm screws, a 4 by 4 cm piece of mirror, and paper clips to make the linkages. The control electronics are pretty simple, based on an STM32 microcontroller with a DRV8825 stepper motor driver and a voltage regulator. Motors are powered from an external 12V supply. An all laptop charger in my case. The microcontroller's firmware drives the motors, fetches the LiDAR data, and sends it to a computer as Cartesian coordinates. Due to the geometry of this LiDAR, it has some mathematical transformations to do. Data is sent to the computer via a serial link through USB. Finally, I made this basic 3D LiDAR viewer in processing. It displays the data as a point cloud with the sensor in the center. The point cloud can be exported to be post-processed and converted to a mesh, for instance. A nice feature with this design is that we can adapt the scanning method to our need. The scan time obviously depends on the desired resolution. For instance, we can do a very fast low-res scan and fill the mesh as we go. This clip is real-time and shows the LiDAR performing a core scan. Of course, we can also do a slow but very high-resolution scan, like in this clip. This project can be replicated for about $40. Its main drawback is the mechanical tolerances due to the 3D printing process. This inherently limits the maximal precision and the durability of this device. This design is described with a lot more details on my website, and the CAD files, code, electronic schematics, and 3D viewer are published on GitHub.